All right. Hi, everybody. I think we're going to get started now. Yeah, thanks so much for coming. It's kind of end of the day of Monday, and I appreciate the opportunity to speak to you. My name is Rob Jan. I'm from Boston, and don't have the Boston accent, but I am from Boston. And today, yeah, we're talking about AI automation, kind of pipelines. So hopefully this is a topic of interest to you, which really kind of experiences from a lot of our customers of working in complex environments, where we're looking to build resiliency into pipelines using APIs and automation. And today we're going to review some success factors and kind of a blueprint of kind of some things that we've seen customers use for building this. And I'm going to do a demo as well with Azure DevOps, so hope that goes well. But that's the plan and the agenda. And just to kind of get started, hope a little participation. Just kind of wanted to show of hands because we're going to get into some of these topics. But just how long, for maybe an application you're working with, does it take to get from the code commit to actually in production? From the time of code commit, the last commit, and then it's packaged and put in production. Is anyone, about 2 weeks? Anyone in about a 2-week time frame? Okay. How about maybe like a week? No? A couple? All right. How about a day? Does it take a day for anybody? Okay. All right. And then anyone in hours? Anyone can get a code change from something in hours to production? Okay. All right. We got a mix. We got a good range. And then how about hot fixes? So on a typical release, there's features, but like what's like an emergency hot fix like built into your code? Just sort of, again, show of hands. Anyone like typically like 5 maybe in a given release? 5 or more? Maybe 1 or more? 1 or more? Okay. How about 0? Is anyone like kind of averaging like no hot fixes? Okay, not a lot there. And then I guess, also like on the production side, once you're in production, when you find a problem, what's sort of that mean time to resolution? Like how long does it take to fix a problem once a problem is found, whether that's deploying a code change or deploying a configuration change? Kind of same thing. Like, does it take like a day or more, to find the problem and fix the problem, typically? How about a couple hours maybe? Okay. All right. Well, and then I guess the question is, with those answers in mind and those thoughts in mind, is it getting easier or harder now that we have all of these, cloud technologies? I guess what we're finding is, your app plus cloud doesn't necessarily mean you're faster or better. It's more complex, and this is where folks are challenged, and that's kind of really what the talk is about today. So what we've done in our company is kind of pulled some of our enterprise customers and kind of tried to establish some metrics around these kind of topics. So these are the questions you guys answered. And we've kind of broken it into, kind of our top performers, we're calling them, the top 95 percentile, and then, kind of like the average. So these are the same questions I just asked you guys, just so this is a reference point. So we're seeing, the top performers are, can do things within days as opposed to weeks. We can do, and this is, I didn't ask you this question, but business impacting deployments. So the bigger the impact, the higher risk that deployment. So the more that you can break your deployments into smaller pieces, that's kind of the objective here. So the less business impacting, changes in a deployment you could make, the better, Same with hot fixes. So minimizing, improving quality, minimizing your hot fixes, and then also going from days to hours to resolve problems. So we have a lot more metrics, but these are just kind of a sample. We're going to get into more technical things today, but this was just some KPIs that we've been tracking and things. So the impediments kind of leading into like, why are we struggling? Why are we in like kind of car wrecks here? It's just the complexity, the inherent complexity of hybrid clouds, modern technologies, containerization, Kubernetes now. Some of you guys are trying that. And still, we haven't transformed our operations away from manual work. We're still running, scripts. It's like semi-automated. We still run a lot of scripts. We manually look at logs. There's a lot of manual operations, and that slows us down. Same thing with lack of information. We have a lot of disparate tools. People aren't looking at the same thing. Things may, take time because of just lack of information in the right people's hands. And it's people, so we have people looking at these things. It's not that people are bad or hiding information. It's just that people are involved, and it takes time to parse and look at things and communicate things. And then, and that's really where it's getting to. What is the root cause? If we have to go through all of that to get to the root cause, these are kind of generally the problems we have. So, and this is, so what do we do? And this is kind of will be the theme of today's. I'm going to kind of walk through this blueprint in detail. And these are just sort of some things that we're going to, kind of introduce as things for you to think about. Really, again, I am from Dynatrace, so we're a monitoring tool, but we do feel that, monitoring your applications is key. Something that can really look at the full stack of the application, go across cloud and non-cloud technologies. And then what we're trying to do, and this is what today's talk and demo is about, is really introducing automation and code quality using monitoring data earlier in your pipelines and lifecycle, and what we call a shift left. So it's really kind of shifting left in your lifecycle to do things earlier. And then enabling right. So because of the dynamic nature of cloud technologies, using tagging and auto-generated rules, auto-sensing rules, this is really in pushing context into your monitoring tools is going to allow, again, accessing information quicker. And we're going to see all of these things. And then the last point is really the utopia of the pyramid of automated self-healing operations. So if we are providing context, we have good monitoring, we know what we want to do and can do things in an automated way, this is really where AI starts to come in, because to get to the root cause without looking through everything, you need some AI and machine learning to kind of get to that place. So let's just jump in. We're going to tackle each topic, and then the demos around the quality, and that's kind of, we'll get into showing you some code and showing you some working stuff. But the monitoring is just some capabilities. So again, this is tool independent kind of pictures, but you want the ability, whatever your automation deployment tool is for provisioning your infrastructure, whether that's cloud or not. These are kind of some typical tools that we see out there in the marketplace, and these are allowing you to get the monitoring tools and the configuration out there. So this is just kind of maybe standard stuff you guys are doing, but that's a key capability that you want your monitoring tool to be able to have the ability to monitor things. Then I mentioned this earlier, it's the full stack. So, it's not just the host, it's not just the web browser, it's like everything in between. It's the processes, it's the services, it's the host. You can be able to build a relationship between those things. And then I mentioned this earlier about tagging, and I think a lot of you are probably already using that with the cloud. I mean, more modern monitoring tools need to be able to pull in the tags that you're setting up in your PaaS platform like Azure. So knowing your environment, the owners, all this type of information. And so this fits into the ecosystem of multiple tools, not just your monitoring tool. It can fit into your service management tool and your deployment tools, because you want to be provisioning and monitoring things by tags, because again, the dynamic nature, it's not host name one anymore. It's, Docker containers up and down. So you need to be automatically detecting things based on these tags. And then kind of another category is just those dependencies I mentioned. So we have complex, interconnected services, in-house, going out to third parties, and having the ability to see those dependencies. And then we'll see some of this in a demo, but showing deployments, events in your tool. So like, hey, I had a spike or some change in the behavior of my app. Why? Well, maybe I just did a deployment. So can you inform your tool and your ecosystem that, hey, I did a deployment, I did a configuration change, I did some sort of testing in the environment, and that may explain the anomaly that I see. Same thing with maintenance windows. So those kind of are a context that we want to capture and be aware of. And then really every modern ecosystem is on APIs. So every tool you have and every sort of enablement of integration happens as a result of APIs. So you need the ability to push events, query problems, query your topology, query information by time series. So this is really paramount. So I actually got a really nice demo of the Azure monitoring. There's a booth in the hub, and they're having a lot of this capability too. So this is really, modern technologies, modern monitoring tools have these kind of capabilities. All right, so moving on to the next thing in the pyramid. So this is the concept of automated code quality, and I have like a little graphic here to kind of show this concept. So hopefully you'll see this concept. Probably, I've talked to a couple people. I listened to the DevOps booth again, and some people are actually implementing this in different ways. So there's different ways to implement what I'm about to show you, and I'll demo one way in a minute. So the idea is like you have a code pipeline, and make some sort of code change or configuration change. And what the concept we're trying to introduce is the concept of a monitoring specification. So if I can define in code how I want to evaluate my system, let the developers and your DevOps team maintain these things, then when I come into some sort of CI/CD situation where I deploy my code, I run a test, I can then be capturing that with my monitoring tool, whatever that monitoring tool is, and then use the combination of using the specification file to query my monitoring tool data through their API. Then I can evaluate whether this code release passed whatever my code quality criteria was. So we refer to this as a quality gate. So people are doing things with functional tests. People are doing this with, like say security, static code analysis. So this is introducing an automated way to do it through a specification file. So then we lead to happy users at the end. So I'll drill into this a little bit more now. So we just step back. So there's an open source project out there called Captain that the group I'm in is kind of developing. And so we have this, and this spec file is kind of a consortium. If you do a Google search for Performance Advisory Council, there's a number of companies that have been contributing to the specification concept, and we're getting various use cases. So there's a lot of blog articles. If anyone wants more information on this and the group that's kind of putting together a kind of a proposed way of doing it, and we'll show this. This is what we call the spec file. So you'll see it's kind of made up of something you want to query from some system, whether it's Dynatrace, Prometheus, or whatever. And the idea is that you're going after time series data. This is all time series data. And so if we can then say, hey, here's something I want to monitor, here's a way I want to evaluate it, and give it a score. So if I'm able to achieve the result I'm after, I can give it a score or not at the metric level, and I can repeat that for other metrics. Then at the end, I have a total score, so I sum up all my scores, and if the sum of all my scores passes my objective, then I can pass or fail. So in this example, he only got 10 points. He needed a minimum of 50 to be a warning. He failed. And so if you can't read the screen, I kind of made a couple Zoom screenshots. So here's an example Prometheus query to go after something from a Kubernetes platform, total bytes. So you could then define your grading or the way you want to evaluate thresholds, upper, lower, severe, et cetera. And then there's that score. And then at the end, you kind of define this objective. So this is what I'm about the demo. So the demo environment I have is we have some source code that's in Git, and we have a perf spec file and a JSON file. We're going to do a build pipeline, which will build the code, run some unit tests, and then create a build artifact that kind of bundles up that perf spec file. So then we move on to a release pipeline where we're going to deploy our code. In this case, it's to an Azure web app, and then we're monitoring it, which could be anything, but in this case, it's Dynatrace. And then we're going to push one of these deployment events that I was kind of mentioning around putting context in there. And then we have this quality gate step, which is implemented, in this case, by a PowerShell script that's going to call a microservice that has this rules in it. So all this code is open source, and the link's up there on the top. And there's another slide where I'll kind of share this as well. But this is sort of our demo environment. So let me go ahead and switch monitors and log in. Okay, so let me just step you through a couple things. So what I have is my Azure account, and what I've done is I have a resource group, and in this case I have two web apps that I've deployed, which are both Node.js applications, and they're running here. And then Pedometer, which is the source code, it's also a Node application, and turned into a micro web service, and that's running as a container app. So I took the code, Dockerized it, stuck it in a container service. And then this is sort of the, because these services are on the fly, I'm kind of used my own kind of consumption plan here. So that's kind of what we have. And then the application looks like this. So it's kind of like a hello world with a little pretty picture on it. But the app has a staging environment. So the URL you can see here came from Azure. And so that's my staging, and then production looks the same. So at this point, just so a little details about this site, it's sort of pre-built with different problems built into it. So when you see problem 1, it's really the green, there's really no problem. So and then problem number 2, built into the code, if I release build number 2, it will internally create 50% error rate. So then that way there's errors coming back, and then again the monitoring tool will detect that. And then build number 3 is normal. So that's kind of our app. And so let's look at our code. So here's my Azure DevOps project. In this case, I've imported the code into my repo. And so again, this is all the Node.js app and some of the graphics that you saw. So then in here, I have my perf spec file for this particular app. I can zoom in just a touch. So it'll look just like I showed you on the previous slide. So there's, going after 2 metrics, 90 percentile response time. Here's my thresholds. I have an average response time, and there's my thresholds, and then I need to get a particular score here. All right, so, and then as far as my pipelines go, I will go to pipelines. I have 2. So I'll just walk you through it. So not too much to see here, but what I have is a build pipeline that, again, some of this is simulated for demo. So what's going to happen is this is a Node.js app, so there's really, what I'm doing is taking the entire program and installing it. There's really no build per se, but just for demo purposes, I said, let's just pretend this is a build step. Let's pretend this is a unit test, because I don't have a unit test. And then this is one of the built-in pipeline steps for publishing an artifact, and it's basically going to take the entire repo and turn it into an artifact. So let's just go ahead and run that. We can watch this. So hopefully, I don't know if you guys have seen DevOps, but DevOps is Microsoft's basically replacement and roadmap in the future for VSTS. So anyone that was using Visual Studio Team Services, this is the cloud version. It kind of was, I guess, GA last fall and really announced. And so there's a lot of work. I think I was at the booth. There's about 600 developers and others building this product. And this is what we're demoing here. So I don't know if you've seen it, but this is Microsoft DevOps. And my job is already run here, but just so give you a quick little demo of this. But DevOps is kind of a self-contained environment from it has dashboards. You can have a wiki site. Again, for my demo environment, I don't have this, but you can have storyboards. You can set this up as a sprint board. You have backlog items. You can move through sprints. And that's kind of what all these features are. And then you can have multiple code repos, and then you have your pipelines, you have shared libraries, you have different pipeline types. There's integrated test cases within this tool. And then I think you have to license this, but with the artifacts, any sort of code artifacts can get published into an artifact store. In my case, what I'm doing, and I think it just completed, my build is attaching my artifact into the actual pipeline build. So here you can see there's a number of steps to initialize this. But again, it was simulating building an app, running a test, publishing my spec. And basically up here is where, in this demo, the artifact of the build is basically a zip file that's attached to this running pipeline. So that's how I'm going to, in a second, we'll be able to access the perf spec file and also deploy the code. So this is the artifact of the build. So then now we'll move on to the next release pipeline, and we'll kind of walk through this a second. So this is my release pipeline. And the way I've set this up is I have a staging. So the first step is it brings in the artifact. So this is bringing the artifact in from the build pipeline. And it's using the latest, if you notice here, it kind of defaults to the latest build. So it's going to bring in the latest build, which I just built, which is a zip file. And then in my staging, what you can see here is I'm going to deploy my code. And then there's a task for deploying into a web app. So it's going to take my artifact, all my Node.js code and static files, and basically plop it into my web app. Then I'm going to push this deployment event. I'm going to capture my start time, run a simulated load test, capture my end time, and then run my quality gate. So, and then the next task is in the pipeline is it's a production. So production is going to deploy to production. And I'm going to push this monitoring event to code. So let's just go ahead and run this, and then that way you can see it in action. I could talk a little bit more, so we'll just create a release. We'll let her rip. And just the details behind this stuff is if I want to push, and this is all in source code, so let me just zoom in a little bit. So what I'm doing is, in this case, this is a shell script that is just calling dynatrace deployment event shell script and passing in arguments. So all this code itself lives in the repo. So I could have put it in line, but so in here, and again, all this, so you know, all this code is all open source, so you can have access to all this stuff too. But when I push like a deployment event, again, it's just a shell script, and what it's doing is taking these parameters, you know, in here, and then calling an API. So this is an API call into Dynatrace to push information. And I'll show you how it gets shown up in the tool, but that's basically what this little script is doing. And then if we look at the quality gate, I kind of did multiple scripts. So this is kind of the power of DevOps. So you can do shell scripts, you can do Python, you could do PowerShells, whatever your scripting language of choice is. But what this is going to do is take an argument of the start time, the stop time, the URL to the web service, take in the perfspec file, and then you'll see this fake out status in a second. So basically it's building this all up, long story short, constructing the payload to send to the web service. And we'll see that easier in the logs, but that's kind of how this code is actually implemented. All right, so let me go back to the pipeline. It's probably chugging along here. And release. So it's actually completed the staging, so let's drill into this, and this is where you can see how things look. So let's look at our logs. I'll zoom in just a touch. So you can see the first thing it did is it downloaded the actual zip file from the passed-in artifact. I'm going to then, this is the output of deploying to the web app, so you can see it's deploying to app staging. It's using some settings. So this number 1 is because I'm deploying kind of release number, the feature set number 1. And then this is some tagging information, so that gets used to tag it. And then this is the URL to my app. And then the next task is that deployment events I was mentioning. So it builds up the payload to call the Dynatrace API. This is just saying it succeeded. This is creating the start and stop time. So the microservice requires it in kind of Unix timestamp. So this is kind of, you know, Unix timestamp, and I printed it out in English, you know, and sort of formatted so you can see what it is. And then the load test is really just a loop for 10 seconds, doing some curl requests to kind of generate some load. So it's really not generating, that's why it runs so quick. Then I have my end time, and then this is where the perfspec kind of comes in. So it's constructed the payload, which is the start time, the end time, you know, this is the contents of the perfspec file, right? And then when it calls the web service, it's coming back with the evaluation. So again, I ran the load test for like a second, so it really has no data, which is kind of why I built this fake in. So the result of the call is a fail, but for demo purposes, I fake it out to be a pass so that we can just quickly get through this. But this is what that stage looks like. So the whole pipeline is now completed. It's moved it on to production. So just to show you on the Dynatrace side and the monitoring tool, you know, we have both applications there. If I look at staging, right, I can now, and again, I won't get into Dynatrace, but this is just to show you the deployment event. So the deployment event in here, I'll just zoom in on it, shows up with this context information. So we did this entity. So then, just to show you the concept, it came from Azure DevOps. I was deploying, you know, kind of feature number 1, which means no problem. This is the hyperlink back to the pipeline, and it was coming from this Azure DevOps project. So again, more information can be added to this, but hopefully that gives you the idea. So now I can know, hey, I did deployment at this time frame. If that kind of correlates to, you know, some strange, you know, response times, now I kind of, at my fingertips, know, hey, this is a result of this pipeline, you know. So let's go ahead and run the next one for demo purposes. So this is a feature of the tool, and we'll demonstrate the fail. So what I have is sort of a secret variable here. So let's deploy problem number 2, which remember is the 50% error rate. And again, just for demo purposes, let's just call it a fail no matter what happens. And And so let's do this. We'll do a release. And so what we're going to expect here is that the quality gate stops the build. So as we go through staging, and what I have running in the background here is, so this is the staging environment. I have, I don't know, there was a little add-in for Chrome. This automatically refreshes my page every 15 seconds, so you'll see it just kind of automatically go. And the same thing with production. So if we go back to a pipeline, the thing's in progress here. You can kind of watch it real time. This is kind of handy. So it's deploying to stage. It's taking the contents, pushing it out. Hopefully you can see that. I'll kind of zoom in a little bit so you can see it doing something. So this is now, see, problem number 2. So in a second, when we see the app deployed, we'll kind of watch it over here. As it gets deployed, this will just refresh, and you'll see problem number 2, just to kind of show you that problem number 2 got deployed. Drum roll on the demo here. Let's see where the pipeline is. Oops, sorry. The pipeline is, okay, so it looks like it completed. So it might take a second for the app to get the code and recycle. So let's just go ahead and, oh, there you go. So it popped, right? So now problem number 2 has been deployed into this environment, right? And if we go back to our run the quality gate, oh, and so our quality gate in this case, so again, it's faked out to fail, but it failed. So now it failed the quality gate. So if we look back in the pipeline, let's go back to the release, you can see right there, it failed. So that bad code change never made it to production. That's kind of the demo here, so good. So the quality gate did its job. So if we want to now try another build, we'll do one more, and I'll just kind of let this run in the background here. Let me just edit this. And so build number 3 is a good build. So we'll just do a pass on this one and save it. Go. And just what we should observe here is that this will go from 2 to 3. So 3 is, I don't know if you can read that, but problem number 3 is back to normal. So, all right, so while that's running, let's just, actually it runs pretty quick, so we'll just let it run, and then you can see it in action here. Did I create a release? Let me create a release. Right, so then over on this side, while that's running, we can just kind of refresh this. And what you can see is, every time we're doing a deployment, now I have 2 deployment events, right? So I had the deployment for problem number 2, if you can read that on the bottom. So you can see we deployed, kind of problem number 2, and this one, the one right before that, we saw that we deployed number 1. And again, this is the hyperlink to the job itself. So let's just look at our pipeline. So it's running. We can watch the application. So this should pop in a second to problem number 3, which is good. Give it a second. There we go, problem number 3. So it's deployed into our staging environment, kind of problem number 3. And then if we watch production, because it will now pass the quality gate, so it's running the quality gate, it's going to allow it to go through this time, succeeded, and now it will then go on and start the deployment of production of kind of problem, kind of build number 3 or, configuration number 3. So anyway, so I think that's the main concept. So let me, just for sake of moving on, let me switch back to the presentation. So now you've seen that in action. So boom, there's my little animation, pass or fail. And so here are a couple more. I'm not going to read all these to you, but just to kind of let you think about, why would I want to use a quality gate and for what reason? So these are some questions you may be asking. Do I have bad code? Is there an architectural change that I really want to get at? So if I run a load runner test or a JMeter test, it's really a black box. I get the response time of the service or the web page, but what was the code actually doing under the covers? Were there something inside the code that you just can't see with the load testing tool? You'll need a monitoring tool to go interrogate it. And these are the types of checks that you can automate through kind of a concept like this. Right. So moving on to our pyramid, we have, again, kind of pushing these events, and I think you saw some of these things. I'll just kind of talk about this a little bit more, I guess. But again, depending on how you automated your release, doing it in an automated way, we may want to push, that if I'm doing blue-green deployments, again, telling your tools that you did a blue-green deployment, so that your entities in your deployed app are actually tagged with that, so that you can then query your environment for, show me the blue entities, show me the green entities. Again, I might have done a configuration change that you can show up. So letting the tools know that you applied a configuration change. Maybe a deployed, which is what we just demoed, is deploying a version. So now you can know, hey, I just deployed this version. Give me the context, the code pipeline URL to get back to when it did. And this, just to show you some more examples, it could be other metadata. So again, I had a couple in my example, but some other things you could see, approvers, you could see the source code it came from, maybe the app owner, maybe, some run books. So this is kind of segue into the next topic, which is, if there's a problem with this thing, how are we going to get to the self-healing? One idea is to inform the tools that maybe there's a hint for the run book that you want to run to do it. So maybe that could go in the data, or there could be ServiceNow where you're doing things where all these run books are stored. So segue to the top of the pyramid here. So the thing that we're trying to address here is to stop an alert in the middle of the night. So anyone that's been operations doesn't want that, right? So the idea is, again, to kind of use the power of a tool that can really get to the root cause of the problem, and that's where the AI part comes in. Can the monitoring tool understand the behaviors of your application to know that there's a problem and pinpoint it? So we're trying to avoid an alert storm and let your monitoring tool be smart to tell you this is the problem, and then do something in an automated way around it. So again, some of the features of a PaaS platform can do auto scaling and can do things, but this is an example. Maybe I'm adding more instances, to provision something with CPU, say, or garbage collection. Maybe I adjust memory settings, or add more memory, perhaps. Blue-green deployment, flip it back, or maybe that's a feature flag. Restarting services. Then, did you fix it? In an automated way. Then automatically update all your tickets. Automatically update your tickets that you have a problem, and then automatically update your tickets that you applied a change to do something. Maybe, but then you have to have some smarts to it, like, did I actually fix it? Do I need to go to the next level of remediation? Make maybe a rollback. That's kind of an extreme thing. Roll the whole thing back. But then you may want to do, again, back to your source control, maybe tell your source control with some other commit comments that, this was bad. Still ongoing? Okay, fine. We can escalate, through maybe your channels like, Microsoft Teams, or Slack, or again, the same like service management tools. And then kind of tying back to the concepts I was showing before, when we, it's like the post-mortem. So once we have problems in production, can we go back and inform our quality gate, perf spec file, add these kind of key metrics, and continue to refine what code quality actually means. So how can we do it? These are just some ideas. So I'm our product doesn't do these things, but just I've experimented and I have some ways of doing this. But one way to simplify or to automate things maybe is Azure Logic Apps. This is kind of a non-coding way to do things like automatically create a work item. You can have branching logic. So there's a lot of power with these Azure Logic Apps. I've been playing with them. So you can build them as code. You can deploy them as code. You can have a whole SDLC around Azure Logics. There is a limitation because it is really kind of just a workflow. But it's a way to get started with the concept. Another way, which is Azure Automation, which is kind of the next level of automation. To automate runbooks. This is something that's built into Azure, so you're really a more sophisticated way of doing this. if you have Ansible, I mean, as an example, that's another way to automate things. ServiceNow has things. So there's different ways to implement it. But just one concept, I found this in a blog article on Medium, that's the hyperlink, but this was just a way to think about mitigation. It's always kind of, do the least invasive thing first. So feature flags is something that has to be built into your app, but that's a sort of a technique a lot of people are doing now, architecture, building these things in, so you can kind of enable and disable things, and that may be combined with, canary rollout. So you can kind of do a feature and target a smaller audience, see if that's looking good, and then roll it out to other people, or if it really is a terrible feature, do a flag to turn it off. And then you can see down the line. So redeploying is kind of more invasive, and so you can see faster versus ever. So I don't know, I just like this slide. I think it's an easy concept for people to get. I have quite a bit of time. I do have some recap and I have some supporting slides if people have some questions about it, but I'm definitely open to kind of feedback and questions. If anyone does want to ask something, just please go to the mic. But I'm hoping these kind of concepts are just what, can resonate with you guys, because it's really, this is kind of a combined picture of the two things. So we really are, pushing context, comparing build to build within some sort of tool like a DevOps. We're using automation quality gates. We are pushing context into our tools, and we're approving onto the next environment. And then self-healing is really kind of trying to introduce this concept of using the same data, using the same tags, using the same context to then drive auto-remediation here. And so again, just one way you can see some of this code, I just recently wrote a blog article with Dan Samito, who's from Microsoft. He's down in Brazil, so we actually worked together on collaborating on we have a working Azure function as well as a standalone micro web service that implements this quality gate. So we published it up on the open source Microsoft site, so that's something you can check out, and it kind of gets into a little more details into what I talked about today. I'm also part of this another open source project called Captain, where it is on cloud native and Kubernetes. So this concept of self-healing and delivery pipelines, deployments is really tied into this ecosystem blueprint that we're working on. So you can check that out as well, Captain. And yeah, so any questions? I mean, I know it's Monday, end of the day, so I try to go quickly through it. We do have a lot of time left, but so if anyone has any questions or wants me to elaborate or show you anything else, I'm happy to do that. Okay. All right. Well, I guess I'll let you go. Oh, we have a question. All right, one question. All right.
Hi. So given that we've kind of seen a little bit of the AI part of it, is there any integration with machine learning that could be had here as well?
Say that one more time. I'm sorry.
Would there be any, since you've shown us a little bit about the AI and bringing that into play, what about machine learning? Would there be an opportunity for a play for any kind of machine learning within this kind of environment or no?
Yeah. Okay. So great. I think, yeah. So the question was just, what about machine learning? Is there a way to incorporate that into this concept? And I would say absolutely. There's, it's really about, especially when it gets into production, it's about being proactive. So I think if you have a problem, and again, I think this is not a strong capability of our product. So I think it's demand for this for sure, to have this feature set where if I'm seeing the same problem every Thursday, and my fix is always, add more, memory or recycle the box or something like that. Can we do some learning? Can there be machine learning to say, hey, I start to see the circumstances that are leading up to your system crashing. Let me even more proactively tell you, or maybe proactively run some runbooks. I think I don't have a working example of that, but I think conceptually we've talked about the ability to do something like that for sure. So it's really, there's a lot with AI. So in our particular case, that's sort of the feedback we're looking for. So it's kind of a discussion about, how to best implement these things. I think there's another question.
Yeah, would you mind going back to, I think, the second slide? It was with the ecosystem breakdown. I thought it was beautiful, and I didn't get a chance to get a picture.
Oh yeah, sure. When you say ecosystem, this one?
Way early on.
This one?
Actually, I think it might have been that one. Oh, and that one. Oh, and that one. Okay.
Well, what I could tell you...
These are all available,
What I could tell you, well, thank you for the positive feedback there. So what I could tell you is, I know all of these slides, once we're officially done presenting it, they lock it in and it becomes part of the proceedings of the conference. So all of this stuff is absolutely available. And if you don't get it, and if you want to email me directly, that's fine too. It's rob.dynatrace.com. So if you want to, not wait for the build proceedings, but yeah, no problem.
So you showed the PowerShell script, which we're actually calling the Dynatrace.
Yep.
Can you elaborate a little bit more what the Dynatrace is doing for it? Because failing the release, you can, even with the integration test, you can fail unit test or something, you can block it. I'm just interested to learn a little bit more what the Dynatrace is doing, especially in this particular case.
Okay, sure. Yeah, I think part of that is, well, let me describe it, and then, so basically, you have to know a little bit about Dynatrace, but you could kind of generalize it a bit. So Dynatrace internally has, as it's monitoring things, there's entities that represent processes and hosts and things like that, and then there's time series metrics for what it's collecting. So in our case, we have an API that can go query that time series data, and you query it saying, hey, typically by tags, show me for this time frame, this metric using this tag, in my case, the staging tag. So I go after staging for this time frame for response time metrics. So in Dynatrace's case, every metric, response time exception is an individual query, an individual time series metric that you can go after. And so what's happening is in the web service of that quality gate, it's basically, it takes this JSON file, right, that you specify, these are the metrics I want to go after, and what's happening in the web service or Azure function example, it loops through this file and says, all right, I want this metric, let me call the API, pull that data. Get the next metric, just loops through them all and pulls the data back. And so it gets sort of a value. So Dynatrace's API in particular has, depending on the metric, has min, max, percentile, account. So you could probably query any monitoring tool data in a similar manner. So it is kind of a static piece of information for that time frame, and that's kind of how it's doing it. Does that kind of answer your question? Okay. So yeah, so that's so you do need a client to go query the monitoring tool, and then it's just wrappered in the ability to pass in the start time frame, and then to pass in the file that lists all the metrics that you want to query.
So does that mean that our service or whatever we are trying to deploy should already be onboarded to Dynatrace, right?
Right. So for any monitoring tool to work, you're going to have to deploy your app that's going to be monitored, and you have to run some traffic through it to collect the actual metrics. So that's kind of a prerequisite to doing it. Right. So it's really run the app, run the code, run the tests against it that generates the time series data that you want to then query. So in the case of what I demoed in this open source project, it's open. So right now we've implemented just Dynatrace and Prometheus as data sources. But with open source, we want to do it. And I've been talking to some of the Microsoft guys about even just the Azure monitoring data. Can we hook that in to make a call and do that? But the idea of the concept is that I can query any monitoring source to get data, configure it in a common file that you can mix and match. So I could go after Dynatrace for data, I could go after this data, go after that data, go to a custom script, and then have it all evaluate as a spec. And even furthermore, which is in the blog article, this concept of a spec file can go beyond just a quality gate. So we could use it for, there's a number of use cases we've thought of. And one is, if I have the specification file defining these thresholds, I could auto-generate alerting rules for production. So I could use the same spec file for multiple purposes. I could use it for a quality gate. I can use it for a health check and environment. I deploy a code. It's not a quality gate, but I use this metrics to query my environment, make sure it's healthy, and say my app is healthy. in post-production, I can kind of use this spec file to kind of continually poll an environment, perhaps. We're working with another testing partner that is looking to auto-generate, test cases from the spec file. So if I have the endpoint, I have the metrics that define what my web service test should be. Instead of writing all these test cases, auto-generate all the test cases based on the spec file. So then again, that's even more automation. So that's the whole idea, is that we want to, if we can have this concept of a spec file, use it to then drive the automation. That's really the idea. So, another question, yeah.
Yeah, one more question. So this is along the line of the first question. So we want to apply some machine learning algorithms to this whole process, but I think one of the requirements that we have enough data. Just like we collect all the information along the time that we know when there are something happened, or how do we deal with it. So just like my experience, so when you getting a senior about the system, so the good thing that you know all the story behind the thing. You know why this alert is setting and why the quality gate is set like this way, and how do you deal with different issues or mitigate it. But the best thing is that people always go to you, right, after some while. Right. And the difficulties relies on how do you transfer your knowledge, or how do a newcomer to read all these alerts, all these gates, they know that why and how the system come into this way. So do you have any comments or suggestions about how do we basically use a system way to collect all this information, accumulate all these knowledges, so that in the end of the day that we can apply some machine learning algorithm to basically make our system more intelligent and more automatic, and also for the junior people, they can learn easily.
Yeah. Wow, that's a great question. Yeah, I mean, I think that's kind of what I mean. My first comment is I agree. I think we need something like that. So as far as how you do that, I don't really have an answer for that just off the top of my head. I don't want to make up something, but I mean, I will say that that's the goal. I mean, we just can't scale people-wise to support all these complex systems. So I think that is a common problem we have, and I really don't. I mean, I don't know if you have any comments to that, Hans. Yeah, so sorry, I don't really have a specific comment other than that's the goal.
Yeah.
And so, but yeah, I think we should try to continue to dialogue about how to best achieve that. But I do think you're right. I mean, it starts with gathering the data, having context to the problem. Know what type of events were taking place to cause the problem, and because that's what's going to feed the machine learning system, right? It's not just the data, but it's the context. Was it, business transactions of a particular type? Was it, certain, environmental changes or config changes that kind of can correlate to that? Because that's what you need, is you need the patterns and something to correlate it, just besides, the response time of the app. So I guess it's an opportunity. Yeah. Thank you for the question. I think that's I guess that's what's ahead of us with all these complex systems. So. Yeah, thanks for the question. Yeah. So, all right. Well, I think we're good. I don't know if there's any other questions. So thank you for your time. I know it's Monday, so thanks so much. And if you have want to talk afterwards, I think some of these topics are ongoing, right? I'm not here to prescribe the answer, but it's really some concepts and some of the stuff you can actually do. So kind of back to the slide. You can certainly. And that's kind of what we're trying to do with this open source project at the end here that I mentioned, this captain. So this is about exploring, if I get to the slide, exploring how do we go about this, and then how do we do it in an open way, because everyone has different tools. So can we establish some sort of framework where things can come in and out of the ecosystem without disrupting everything? So it's really, this is, I think all of us are working with this problem now. So, all right. Well, thank you so much. Appreciate the time. Thank you.